Alright, this video is about multiplying and dividing fractions. I'm going to throw an example out here and use this to illustrate what I'm talking about. So, let's say we had a problem where we were supposed to multiply 2/3 and 3/4. What I'm going to do is just multiply straight across. So I'm going to go 2 times 3, that equals 6. 3 times 4, that equals 12. And that's literally my answer. Multiplying fractions is probably one of the easiest things you can do with fractions, if not the easiest. So maybe the one more thing you want to do here on this problem is just take the 6/12 and rewrite it more simply. You could rewrite this 6/12 as 1/2. But this step is not necessary. The multiplication of the fractions is just right here. It's just multiplying straight across. Now what about division? Alright, let's say we were going to divide. So I'm going to think of another example. Okay, how about 5/4 divided by 1/3. The way you do this is very similar to multiplication, but there's just one extra step. And that extra step is that you need to take this second fraction and flip it and rewrite this as a multiplication problem. So I'll illustrate what I mean. Okay, so instead of 5/4 divided by 1/3, I'm going to rewrite this problem as 5/4 times 3/1. So these are actually the same. This is the same problem now. The reason why this little trick works is because division and multiplication are inverse operations. They're reciprocal operations. And so 1/3 and 3/1 are reciprocals of each other. So when if you do a reciprocal here and a reciprocal here, the reciprocalness, I guess, if you want to think of that as a word, cancels itself out. So that's the theory behind it. But in practice, to divide, all you do is you just take the division problem, you look at the second fraction, you flip it, and you change this sign to multiplication. And then you multiply straight across. So I'll go through that process one more time. To divide, what you do is you take the second fraction, you flip it, and you change the sign from division to multiplication when you rewrite the problem. So now this is a multiplication problem, just like we did in the first example. So I'm going to just multiply straight across. 5 times 3 is 15. 4 times 1 is 4. That's literally all there is to it. I guess maybe the one more thing that I would point out is that in some cases you don't actually have to go through the multiplication, right? So I'm going to rewrite this this first example that I used here, okay? Because I think that it's going to be a good example of what I'm talking about here. So let's look at this again, all right? So it was what? It was 2/3 times 3/4, right? The way I did this first was I just went 2 times 3 is 6, 3 times 4 is 12. But there's actually one, there's a simplification that I could make to begin with, and it would save me a little bit of work, right? So do you see how there's a 3 on the top, and here there's a 3 on the bottom? Anytime you have a multiplication problem where you have some fraction times another fraction, if you have the same number here, where one of them is on the bottom and one of them is on the top, and it's the same number, you can actually literally just cross that number off and look at these two numbers and go 2/4. That's just a little trick. And by the way, 2/4, right? Isn't that the same as 1/2? Yeah, that makes sense because 1/2 and 1/2. It's what we ended up with. So I just wanted to point that out. This is called canceling factors. So if you see this in class, or you'll know what they're talking about. Anyways, that's basically it. I would say, as a final note, don't get this confused with adding and subtracting fractions, because it's very easy sometimes to think that you have to, you get in this mode of finding a common denominator so often that you think you have to do it, but you really don't. Multiplication and division of fractions is probably the simplest thing you can do with fractions, and I guess that's a good thing. So anyways, thanks for watching.